Okay, so what is a stationary wave? Now, the stationary wave, the definition is exactly the opposite to progressive waves. So progressive waves you will define as wave where the wave profile moves and energy is transferred from one point to another. So stationary wave, just the opposite. Waves where the wave profile does not move and energy is not transferred from one point to another. So what does it mean? When we look at the stationary wave afterwards, I show you. I want you to observe whether the wave profile, that means the shape of the wave, does it travel left or right, or doesn't seem to move left or right. That's what it means. If it doesn't seem to move left or right, then it means it's stationary. But how do we generate stationary waves? Now, there must be two waves traveling in the opposite direction. So not in the same direction, but must completely opposite direction, same frequency, same amplitude, same speed, same wavelength, everything identical. Just come in opposite directions. So you can imagine you have two waves, one here, one here. So as they come together in both directions, sometimes they will overlap exactly, so you give you constructive. Sometimes they will move away, then they will actually be opposite to each other, then they give you destructive. So we look at the video, how it looks like. Okay, so I want you to look at this wave when we're going to start playing. You will notice that there are two progressive waves. One is the blue wave, one is the green wave, right? The blue and the green wave. Can you see them moving in opposite directions? Okay. So you will notice that the blue wave and the green wave, which are progressive waves, when they meet, right, they will obey the principle of superposition. So the resultant wave is actually your yellow color wave. So this yellow color wave, let's look at whether it travels or not. Okay, now you observe the yellow color wave. Can you see it's moving up and down? So this is what you will see. You won't see the blue wave, you won't see the green wave, you will only see the yellow wave. And the yellow wave is just moving up and down. Is it moving left or right? No, right not? Neither, right not? So therefore we call it a stationary wave. Understand? So a stationary wave doesn't mean it doesn't move at all. It still oscillates, but it just doesn't travel. So why do people want to find stationary waves? Now, in musical instruments, whenever you play a note, let's say you blow the flute or you blow a recorder, the note that you make is because of stationary wave. There's resonance there. When you play a guitar or you play a piano, also there's stationary wave. But there's also another use of stationary wave, which is to generate a stationary wave from a progressive wave and then find the wavelength of the progressive wave from the stationary wave. Now, how do we do that? Now, let's say I freeze. So do you see that at this time the blue wave and the green wave overlap exactly? So can you see the wavelength of the blue wave or the green wave, which is from here to here, right? Can you see it's also equivalent to the wavelength of the stationary wave from here to here? Can you see that? So therefore, the wavelength of the stationary wave that is produced by the two progressive waves will be the same wavelength. And how do we determine the wavelength of a stationary wave? It's actually much easier than determining the wavelength of a progressive wave. In a progressive wave, since the wave is moving, so how can we actually catch it to measure the distance, right? But in the stationary wave, we don't have to catch it because you see there are points along the stationary wave which enables us to find the wavelength easily. First is what we call a node. So what are nodes? If you look at the points here, here, here on the yellow wave, on the yellow wave, I want you to look at these points. These points will never move. So these points are called nodes because they said the positions where the amplitude is always zero. Okay, so I let it play again. So can you see if I point at this position here, it never moves? You see?
Yeah.
Right, it never moves, right? And in this position also it never moves, right? So these are called nodes. There are also positions where you have maximum amplitude. Now, if you look at the yellow color wave, every point moves up and down, right? This point doesn't move, this point doesn't move, but in between these 2 points, they all move up and down, right? But this point moves the most. Can you see it goes to the lowest? It also goes to the highest. Right? But the next point here, it doesn't go very high. It also doesn't go very low. But they are all in phase. Okay, I'll come to that in phase later. But anyway, so these positions where they have the maximum amplitude, these are what we call as antinodes. And if you were to actually take a microphone and place at the position of the nodes or antinodes, right? For example, If you place a microphone here or here along the stationary wave, it will forever give you 0. So that means if let's say I move the microphone along the wave here, once I reach the notes, it will always give me 0. But once I reach the anti-notes, it will always give me maximum amplitude. So what will happen? If I'm here, it shows me 0 amplitude. Here, it shows me a small amplitude, the microphone. Then if I show here, slightly bigger, here is the biggest. Then if I move here, the amplitude smaller, then here now will move already. So of course, a microphone you connect to a CRO, then you will see this. So then you just have to measure the distance from here to here, which is between a node and a node. Because at this position where the CRO shows 0, here also shows 0, so you find the distance between them. How many wavelengths is this from here to here? Half a wavelength. So half a wavelength of your stationary wave. So can you find the wavelength of the stationary wave?
Yeah.
Let's say this is 2 meters, half a wavelength, so one wavelength is 4 meters. So that will also be the wavelength of the progressive wave. You understand? Or you can take from anti-node to anti-node. So you move here until you get maximum reading, then you continue to move until you get maximum reading, then you find the distance between the two, which is also half a wavelength. Okay, so that's how we actually find the wavelength of the progressive wave from the stationary wave. But I also want to mention to you something special about the movement of the molecules. Now, if let's say this was a water wave, or let's say this is on a string or whatever, what you will notice is that between the two nodes here, you look at the yellow color wave, every point between these 2 points, they will move up and down together. Can you see that? I will show you. Can you see that every point here are actually moving down? They stop at the lowest point together. They all reach the middle together. They all reach the maximum together. So they have different amplitudes. That means if I take this point, it only oscillates like that. If I take this point, it oscillates like that. If I take this point, it oscillates like that. But then, what is the difference between them? Just the amplitude. But what's the similarity? They are all in phase. So for stationary waves, any point between two nodes must always be in phase. Now, in a progressive wave, no. You look at the progressive wave, you look at the green or the blue wave, they all take turns to move up and down. When one move up, the other one move down, they all will be moving out of phase one. But in a stationary wave, between two nodes, they must be in phase. So never confuse progressive and stationary. And if I take a single node here, I will notice that on this left hand side and the right hand side loops are moving opposite direction. Can you see that?
Yeah.
This one moving up, this one moving down. Then after that, this one move up, this one move down. So on either side of a node, every oscillation here is 180 degrees with every oscillation here. So every oscillation here, 180 degrees every oscillation here. So, but every oscillation between these two nodes also in phase. But every oscillation here, 180 degrees with every oscillation here. Do you understand? Right? So that is a specific characteristic of stationary waves. So being in phase, that means when we say every point here being in phase, it doesn't have to be same amplitude. As long as they move up and reach the maximum together, reach the lowest point together, reach the zero together, they're considered to be in phase. Okay?